In this video, we're going to look at the probability of the intersection of independent events. So the product rule for the intersection of independent events says that if E1 and E2 are independent events, okay, and remember independent means that one event has no effect on the other, then the probability that E1 and E2, that both of them happen, is just the product of their individual probabilities. So we're asked to determine the following probabilities using the product rule for the intersection of independent events. Write your results as a simplified fraction. So we're told that two coins are flipped, okay, and the coins are independent. What you flip on one doesn't affect what you flip on the other. And we want to find the probability that both coins land on heads. So that both tells us that it's an and situation. So we want to find the probability that one of the coins lands on heads, then the other, and then we'll find the product. Okay. Well, for a coin, there's two possible outcomes, and one of them is heads. So actually, for each of the coins, the probability of heads equals 1 out of 2. So the probability that both coins land on heads is 1/2 times 1/2, multiply the numerators and denominators, and we get 1/4. Let's look at the next one. Two cards are drawn from a deck of 52 cards. The first card is replaced before drawing the second card. So that's how we know that these two cards are going to be independent events, because since you're replacing the first card before you draw the second, it's just like drawing a card from two separate decks. They have no effect on each other. So find the probability that the first card is a heart, and so that tells us that it's intersection. The second card is a jack. Okay, so we need to find these two probabilities and then find their product. Okay, so let's find probability of a heart, probability of a jack. Okay, and we know it's a total of 52 cards. Let's look at a deck of cards. Okay, so here are hearts. Notice it's 13 out of 52, but remember we can look at this. There's 1, 2, 3, 4 rows, and they're equal. So the hearts is 1 out of 4. Okay, and the second event we were looking for was that the card is a jack. There are 4 jacks, or 1 out of these 13 columns. So the probability of a heart, well, 1 out of 4 cards is a heart, okay, and 1 out of 13 cards is a jack. Okay, so you could multiply the original, 13 out of 52 and 4 out of 52, but you'll need to simplify either at the end or along the way, or you can do that on your calculator and have it simplify. So this product, 1 times 1 is 1, 13 times 4 is 52. Let's look at the last one. A single digit between 0 and 9 is randomly chosen, and a single letter from A to Z is randomly chosen. So those are independent events. Choosing a digit and choosing a letter do not affect each other. So find the probability that the number is 7, and, so that tells us it's an intersection, the letter is a vowel. So we should see for the single digit from 0 to 9, there's 10 possible outcomes. So we want number is 7, and one of those 10 outcomes is a 7. And now the probability that we get a letter that's a vowel. First, remember there's 26 letters in the alphabet, and A, E, I, O, and U are vowels, sometimes Y, but we're going to pretend like it's not sometimes Y. So 5, let's just write that in case you forgot, A, E, I, O, U. 5 letters are vowels. The other letters are called consonants. So if we find this product, 1 out of 10 times 5 out of 26, we can simplify factors before we go, or you may do this on your calculator, whichever you prefer. 5 and 10 have a common factor of 5, so that cancels to 1, this cancels to 2. And now I can just multiply across, and I know it will be simplified. 1 times 1 is 1, and 2 times 26 is 52. Oh, that's the same as the last answer. That is a complete coincidence.